We are going to learn about the confidence interval while we are working with the regression models. There is another video on the sum of square of regression analysis. In that video, we learned about how can we find out beta null and beta 1 when we have our regression model, and what are the parameters of those. Like, for example, what's the expected value for the beta 1 or the variance of it. Also, what's the expected value of the beta null or the variance of it. And regression model is one of the empirical models that we would have. Like, for example, you want to find out the connection between the temperature and the pressure in the, let's say, distillation column, or you want to find out the relation between the airline ticket price and the oil price. So all of these ones are we can find it with the regression models. How does it work is that we have a set of data. Based on those data, like x and y, the observation for x and y, so we're going to find out beta 1 and beta null. And for sum of the square of the xy, xx, and yy, it's good that if you look at the other video that we have on the sum of the squares. So let's say we have this beta 1 and beta null. We have two more items that we are interested to find out the confidence interval of that in the regression one. One is the mean response. Mean response means that, okay, so I have my model. What's going to be the mean response, mean output at the x equal to x null? So when we want to read it, we would say that mean estimate, right? You can see here, mean estimate of our y, like our y, at the x null. And then for this one, we have the variance of that as well. And the mean estimate is equal to beta null estimate plus beta 1 estimate x null. The last category is the prediction of new observation. So we want to find out the interval for the future amounts, like future values. So based on this regression model, we want to know that, so what's going to happen in the future? What will be the confidence? If you want to apply this model that you made for the future values, what would be your range, right? So we're going to talk about all of these things. What you can see for beta 1, beta null, the mean response, and also the future observation, look at here, for all of them we have the variance. So let's look at the variance. The variance of the beta 1 is like sigma 2 if we have the variance of all the data that we have, like for the population. It's going to be sigma 2. If we don't have it, we are going to find out the sigma, the variance, we're going to find an estimate for it. So it's going to be sigma 2 estimate over s sum of the square of the x's. The variance of the beta null, it's very similar to this, but we have sigma 2 times, and then in the parentheses we have 1 over n plus x bar power 2 over sum of the square of the xx. These two, when you look at it, the variance of the mean response is like sigma 2 times 1 over n plus, compared with this, it's exactly the same except one part, that here instead of x bar square, you have x null minus x bar square. So that's this one. And then the variance for the prediction, like for the new observation, is a little larger than this one, which is like sigma 2 times 1 plus. So you add like 1 in the bracket plus, and the rest is the same as what we had on top. So why I'm telling you like this? Because the next step is exactly the same approach for all of this. When like finding out the interval, the confidence interval for these, it's exactly the same equation. The only thing is that with this variance, which represents kind of error, so we are gonna find out the standard error, and then we are gonna put in the equation of the confidence interval. Before going further to talk about the confidence interval, I drew this one to show you something. Look at here, we had an example before that we have the fossil fuel consumption, and we want to find out the greenhouse gas relation between the fossil fuel consumption and greenhouse gas emission. This line here, I had the data point, so this line will be my regression line. So for your regression line, you're going to have like beta null, beta 1, x and e, right? And then what you're going to have, these beta null and beta 1 estimates, they are they're valid for your sample. So think about it. I'm talking about the whole world, and I want to see the effect of these consumption on the greenhouse gases emission. So I can't go to all of the refineries and all of the places, power plants that they are using the fossil fuel, or all the homes that they have furnace and they're using like fossil fuel, and check to see that what will be the effect of, like, get the data for them and compare it to the greenhouse gases emission. It doesn't make sense at all, right? It's not possible. So what are we going to do is that we are going to get samples, like from different countries, and then from each cities and area and different zones. So we're going to get data point. We're going to make this model based on that sample. Then I want to see that, okay, what about if I want to add it to the population? If you want to expand it to have a valid model for your population, all the time when you make your regression model, you need to make your confidence interval for that model. So you want to see that my model is like valid between these two. Like, this is the line that I have for the model, like let's say my nose, right? This line. And then I want to say that between this eyes to this eyes, this area is the part that is going to be my model, regression model for the population. So for this, drawing this one, we need to find out the confidence interval of the mean response. So we're going to find it. Then I'm interested to find out what's going to happen in future. So I have my regression model. Let's say I have this regression model, and I want to see that, okay, so can I apply it for the future? We call it prediction interval. This prediction interval is like that. For sure, the variances should be larger, and we talked about that. So the variance is like this. The prediction interval, like the type of the confidence interval that I'm going to have for this one, is going to be between this line and this line. So you can see that here I wrote down prediction interval. These two lines are the prediction interval. These two are the mean response interval and the confidence interval of the mean response. And this is the regression line that we have. So now let's go and write down this regression, like confidence interval for this regression model or regression line that we have. Okay. We have this general rule, and we talked about that before as well. So the general rule says that whenever you're interested to find out the confidence interval of your parameter, if your parameter is like mean, proportion, these betas, or like the parameter of your regression model, or the mean response, or even the prediction, like future value based on your model, in that case, we would say whatever my parameter of interest is. So let's say the parameter of interest is theta. Theta. Between, we said that we have interval, right? So it's going to be theta estimate. So this theta estimate is going to be beta 1 estimate, for example. Or it's going to be like y null estimate. Any of these parameters that we have. Then plus minus. So we are going to get something from the table. For all of these ones, we are going to get it from T table. So T table, and based on the value of the alpha is two-sided, it's going to be T at half of the alpha, and the degree of freedom is n minus 2 here. And then we multiply it by the standard error. That's the only part that is different for these ones. The same equation, so it's going to be a standard error of this theta estimate. So times the standard error of this theta estimate. What is the standard error? It's the square root of this variance. So it's the square root of the variance of that theta estimate that I have, whatever it is. So when you think this way, you will see it as a piece of cake, right? All of them, they have the same methodology. So of course, if I want to write down this one, let's see if I want to write down what's going to be for the beta null. So I'm interested, my theta is beta null. So my beta null is between two numbers, right? And then for the, I'm going to have here beta null estimate, beta null estimate minus plus t, half of the alpha n minus 2. And here t, again, half of the alpha n minus 2. For a standard error, I'm going to get the square root of this. So I will write down here the square root of this variance of the beta null estimate. And the same thing is going to happen here. So I'm going to have the square root of the variance of the beta null estimate. So we are going to do exactly the same things for this one, for this one, doesn't matter. So it's like that you're going to change your parameter of interest and your standard error, the t is going to be the same. So for all of these ones, our degree of freedom when we are going to work with t is n minus 2 because we have like beta null and beta 1, right? So it's going to be n minus 2. The rest is going to be the same. So we are going to, in this lecture, let's say video lecture, we learned about how can we have the confidence interval. So if you want to remember it while you are working outside the, let's say, an industrial application, or case studies, think this way. Your parameter of interest estimate plus minus something from the table. It can be T table or Z table. If it's proportion or the category, first category of mean, I'm saying that in parentheses. So it's going to be Z table. The rest of them is going to be T table. So you would have your parameter of interest, the estimate of it, plus minus something from the table, times your standard error. That's it. So it doesn't matter really that if you're working with you're interested in beta null. When you look at these equation in statistics, without knowing the general form of it, it looks like, wow, what's this? But when you know that, okay, so it's, in fact, you find some estimate, and then you're going to try, this t is like, you're going to be a little more conservative. It's like that you're going to add whatever a standard error. A standard error is the square root of the variance, and variance comes from the error as well, right? Like the deviation that we would have from the mean. So it's like that you would say, okay, so I have my variance. I'm going to get the square root of it to have the same unit with this theta. Right? Multiply it by something to make it a little bigger. And then you would say you would add it to or subtract it from your estimate. That's all. So for any of these, the methodology is the same. It's concluded. For the confidence interval, the methodology is exactly the same, except for one case, which is that when we are interested to find out our parameter of interest is variance. So we have a video about that. Except that one, the rest of them, like you're interested in mean, you're interested in proportion, you're interested in beta null, beta 1, like the parameters of your regression model, you're interested in mean response or the prediction of what would be the next observation, like future observation, all of them, they have the same rule. Your parameter of interest is going to be between two numbers, which is going to be the lower bound is going to be the estimate of the parameter of interest from the sample minus something from the T table or Z table times a standard error, and the upper bound is going to be that estimate that I just talked about that, plus something from the table, which is based on the alpha is going to be T table or the Z table, times your standard error.